We're still taking a look at probability, but this time we have to take a look at independent and dependent events and how that affects probability. Basically, it's going to be start looking at these situations. Well, what's the probability of this happening first and then this happening right after it? It's looking at the probability of multiple events and making sure that what you want to have happen happens first and what you're expecting to happen happens second. What's the probability of that occurring? So before we jump into that, let's just take a look at independent and dependent events, and then we'll fit those together to see about how to find the probability. So first off, independent events, that means like the first event is not going to have anything to affect the second event. So what's the chance of that white dice rolling right here, rolling a 6? It'd be 1 out of 6 because there's 6 sides of that dice, and only one of them has the number 6 on it. Now, when I go to roll the red dice, what's the chance of this red dice rolling a 6? Well, that's got 6 sides, and one side has a 6 on it, so it'd be 1 out of 6 also. These two dice do not affect each other. So just to drive that point home, does the white dice affect the red dice? No. So we call that independent, okay? Now, um, another scenario that we could take a look at is a spinner. What's the chance of spinning a 5 on this spinner over here? It'd be a 1 out of 8 chance because there's 8 areas and only one of them has a 5. If I go to spin it again, what's the chance of spinning a 5? It would still be 1 out of 8 because that first spin does nothing to impact the second spin. So does the first spin affect the second spin? Absolutely not. That's the reason we consider it independent of each other. Okay. Now, if you're taking a look at a golfer, there's a lot of different things that go into whether or not it's a good shot. But this would looks like it's pretty good weather. He's probably got some skills because he's got the right equipment. He's actually got golf spikes on. So who knows what the probability is, but that's a good situation for a golfer to be in right there. What about this situation? This would be more dependent. If we said that, hey, what if the golfer broke his leg, and you can see that, this person's got their leg in a cast right there, that event is absolutely going to affect how well their shot's going to go because he can't even put his foot down on the ground. So dependent events are where the first event affects the second event. Okay? Now, if we look at the parking lot right here, we see that there are 4 parking spots, and I've got them highlighted, that this car could go and park in. What's the probability that this car, if it was truly random, and it's not, but if it was truly random, what's the probability that this car would park in this X spot right here? Well, there's 4 spots, and there's only one X there, so it'd be a 1 in 4 spot. And I went ahead and I parked the car right there in that spot. So now when the second car comes driving along, there's only 3 parking spots left. So that first car affected the probability of the second car getting a parking spot because now this second car only has a 1 in 3 chance of parking in Y. If this first car never parked in that first spot, the second car would have had a 1 in 4 chance. So that second car has different odds, has a different total number on there. So we would call these events dependent. Now, all of that is to just bring home this main point. Independent events don't affect each other at all, but dependent events, they really do affect each other. So when you look at these scenarios, you're trying to ask yourself this question: do they affect each other? That way, it helps you be able to build the probability. Now, let's go through and actually look at what's happening after we understand independent and dependent events. What's happening? If you have a quarter and you flip it twice, what's the probability that you'll get heads both times? Well, the way that I'm going to teach you is to do this: determine each event. The first time that you flip that quarter, for this one right here, you go, what's the odds that this quarter will land on heads? And you'd say, hey, it's 1 out of 2. But then we ask ourselves, okay, so what's the odds that the second quarter would land on heads? Well, the first flip doesn't affect the second flip at all. It's independent of each other. And you'd say, well, it's still 1 out of 2 for the second one. But what are the odds that I can get 2 heads in a row? What you do is after you figured out each individual probability, you just multiply them together. And 1/2 times 1/2 is 1/4. So you'd say you'd have a 1 out of 4 chance of flipping that quarter twice and getting 2 heads. So that's the math behind it, and that's what I'm going to teach you to do. Go find the probability and then just multiply. I do want to show you why it works, though. If you were to flip a quarter, absolutely you could get 2 heads in a row, but you could also get a heads followed by tails, or maybe you get tails first followed by heads, and of course you could get 2 tails. But we're interested in, hey, what about if we get 2 heads? So we've got a 1, and that's where the top number came from, the 1, out of a 4 chance. See the 4 different possibilities? That's the reason we'd say we have 1 out of 4. So you can make a little chart or a graph like this to the right, or you can do the mathematical multiplication of the probabilities right here too. Also wanted to point out that if you had it as decimals, you could say 0.5 times 0.5, because that's the same as half, is equal to 0.25, which is the same as 1/4. Okay, so you can use it with decimals also. Now let's take it even further. What are the odds that if you flipped a quarter 3 times you'd get heads, tails, heads? Well, these are independent events, so it's 1/2, 1/2, and 1/2, and we just multiply them, and we'd say, hey, we got a 1 out of 8 chance, because this first flip doesn't do anything to affect these other flips. Okay, it's independent. That's the reason it's always 1/2 like that. Let's take a look at why. You could get 3 heads, and here's some other possibilities where that tails might come in there with the 2 heads, you know, in the order. You could also get 3 tails, and then we do the same thing with the head. We just kind of keep moving it back. These are the only 8 possibilities that could happen. We're interested in heads, tails, heads. So that's where the top number came from. That's the chance of that happening out of the total, which was, let's see, 4 on the left, 4 more there. That'd be a total of 8. And that's where that bottom 8 came from. So that's why the multiplication works. If you multiply the bottom, it tells you how many total possibilities could occur. Well, 2 times 2 times 2 is 8, and here we go. Here's the 8 possibilities down here. And the top tells you how often, you know, that would pop up out of those total. It's only once. Very last one. I know it's a longer video than normal. If you have a bag of marbles and you have 2 red marbles and 2 blue marbles in it, what's the probability? What's the probability that a person can randomly draw a red marble and then draw out a blue marble? Okay, so the chance of drawing a red marble, well, that'd be 2 out of 4, and you know, let's simplify that down to 1/2. What happens though with the red marble? You know, what happens with this red marble? Let's say you reached in and you grabbed that one red marble. Well, you're going to be pulling it out of the bag, so it's going to be, you know, taken up and gone. And so you had a 1 out of 2 chance of getting that red marble, but when you go back to draw the blue marble, they're dependent events. You see how the first event messed up the odds for the second event? It changed it. So now you've got a 2 out of 3 chance for drawing a blue marble. So what's the odds of drawing a red marble followed by a blue marble? You're going to take these 2 numbers and you're going to multiply them. So 1/2 times 2/3, what you get is 2/6. What's this simplify down to? 1/3. You'd have a 1 out of 3 chance of drawing a red marble and then a blue marble. The only thing that we really need you to understand about independent and dependent is whether or not the first event affects the second event, and it will make sure that you set it up correctly. Like you can see how with the red marble gone, we've only got 3 total marbles there, and 2 of them are blue, and that's where we get the 2 out of 3. And then once you get your 2 probabilities, just go through and multiply them, and that's how you get your final answer.